Hello, welcome to this tutorial on coordinate geometry of a circle. We'll be looking at equation of tangent to a circle. This is the second video on equation of tangent to a circle. In the first video, we made use of derived formula to find the equation of tangent to a circle. But in this video, we are going to be using the calculus method. So we have a problem here to solve. The equation of a circle is given as x squared plus y squared plus 2x minus 2y minus 16 is equal to 0. Find the equation of the tangent to the circle at the point 2, 2. So in our solution, we said we are going to use the calculus method. We find the gradient function of this relation, knowing fully that if you have the circle and the tangent at the point 2, 2, the gradient of the circle at this point is the same as the gradient of the straight line. So it is based on that principle, we are going to find the gradient of this line by finding the gradient of the circle at the point 2, 2. So we are going to apply implicit differentiation. We differentiate term by term. So the derivative of x squared is 2x. Then the derivative of y squared is going to be 2y dy dx. The derivative of 2x is 2, so we have it as plus 2. The derivative of minus 2y is going to be minus 2 dy dx. And the derivative of a constant is 0, so we have the relation to be equal to 0. We collect the terms with dy dx and the other terms. So what we do is I'm taking this to the other side, it becomes 2 dy dx, and also this one now becomes minus 2y dy dx. Our 2x plus 2 will still be maintained. We factor out dy dx here, so we have dy dx. 2 minus 2y is equal to 2x plus 2. Dividing both sides by what we have inside the bracket, we have dy dx to be equal to 2x plus 2 over 2 minus 2y. We can multiply each term by 1 over 2 since 2 is common. At that point, we are going to have the numerator to be x plus 1 over 1 minus y. We then go ahead to find the gradient. Since this is the gradient function, so the gradient of the circle, which is invariably the gradient of the straight line at the point 2, 2, is dy dx at x is equal to 2 and y is equal to 2. So we substitute the x equal to 2 and y equal to 2 into this gradient function. So we have 2 plus 1 since x is 2, and then we are going to have 1 minus 2 as the denominator. So simplifying this, we have the gradient to be negative 3. So we've gotten the gradient of this circle at the point 2, 2, which is the same as the gradient of the straight line, which is the tangent to the circle at the point 2, 2. We then use the relation for equation of a line given the gradient and the point, which is y minus b equal to m into x minus a. Our a and b will be 2, 2, which is this point. Substituting a equal to 2, b equal to 2, and m equal to negative 3, we have y minus 2 is equal to negative 3 into x minus 2. We expand these brackets. Negative 3 times x will give us negative 3x. Negative 3 times negative 2 will give us positive 6. We bring minus 3x to this side, so we have 3x then plus y is equal to 8, because if you take this minus 2 to the right hand side, it becomes 6 plus 2, giving us 8. Therefore, equation of the tangent to the curve at the point 2, 2 is giving us 3x plus y equals 8. And that's all for the solution of this problem. We've successfully found the equation of tangent to the circle x squared plus y squared plus 2x minus 2y minus 16 equals to 0 at the point 2, 2 to be 3x plus y equals 8. Thank you for watching. I hope you enjoyed it. Please check the description section of this video on our YouTube channel to get the link to other videos on coordinate geometry of a circle. Until we come your way again, goodbye.